Okay, I am going to walk you through this example of a pedigree chart, fully creating the pedigree chart down here for the traits given. So it says you must make a pedigree chart from the descriptions given. Tell whether it is autosomal or X-linked and whether it is dominant or recessive. Also state which type of muscular dystrophy the pedigree could be based off of the list your teacher has given you. Label the pedigree with the names and individuals. So we're not going to deal with the type of muscular dystrophy. You're just going to determine autosomal or X-linked, dominant or recessive. Okay. So part A, Chad and Veronica got married and had Brittany, Kristen, and Harry. So Chad and Veronica got married. So we need to start with Chad and Veronica. We start with Chad being a male, married to Veronica being a female. They had 3 kids, Brittany, Kristen, and Harry. So we're going to draw the line down, and then we're going to draw Brittany, Kristen, Harry. It was discovered that Harry had muscular dystrophy. So if Harry has muscular dystrophy, we're going to have to color in Harry. Brittany married Larry. And had Stephen and Stephanie. So Brittany married Larry. So Brittany is over here. Brittany married Larry. And Larry had, and they had Stephen and Stephanie. So Stephen, male, Stephanie, female. Stephen also had muscular dystrophy. So here, muscular dystrophy. Larry's right here. Larry's brother Barry also had muscular dystrophy, but neither of their parents had the disorder. So if we look at Larry's brother Barry, we can add over here Larry's brother Barry, and we also know that neither one of their parents had the disorder, but Barry did. So first thing you need to figure out is this sex-linked or autosomal? Well, if you start looking at everything here, we have 3 males and 2 females, no females that have the disorder. So more males or all males, no females is going to give you X-linked, recessive. Okay, so remember, X-linked recessive if it's all males that have the disorder. X-linked dominant if it's all females, and then if it's evenly distributed, it's going to be autosomal, and then you can figure out based on if it skips generations, recessive versus dominant. So we're going to be X-linked recessive. So if that's the case, I'm just going to go through here real quick and show you how you can show this. If it's X-linked, remember, so we're going to do muscular dystrophy, so I'm going to use a D, well, let's use N for normal, so no disease, big N, X little n for muscular dystrophy, and Y, remember, is our male chromosome. So over here, this is Stephen, and he is affected, so X little n Y. Female here we know is X big N, but we don't know what her second one is, and we might be able to figure that out, but we'll see. Okay, X-linked recessive always comes from mom. So mom is not affected, so she's normal. but she must be a carrier. Dad is normal, so X big N Y. Okay, over here, brother Barry is affected, X little n y. Up here, dad is normal, X big N Y. Over here, brother is affected, X little n y. And finally at the top, normal, X big N Y. Okay, this mother does not have the disease, but her son does, so she must have passed on a little n, so she must be heterozygous. This daughter, we don't know. We know that she's X big N because she doesn't have, but we don't know what the second trait is. This mother passed on the recessive, but is not, so must be X big N, X little n. Okay, so as you look through this, we can fill out in the Punnett square or in the pedigree chart based on what the kids have for genotypes and what the parents have for genotypes. You can determine what the what the traits are for the babies, okay, for the individuals that are affected, that are not affected. And you might have some that you cannot tell if they are homozygous dominant or if they're heterozygous, and with that you just leave a blank for the second piece there, okay? So this is how you complete this entire Punnett square, and what we're going to do is you're going to do B and C on the back of this paper for homework.